This is question 9 from the June exams in 2020 from Cambridge International, and it's paper 1-1. In the description below you'll find a link to an image of this question, and I recommend to try it before you look at the solutions. In this question they give us this one equation here, y is equal to 3 minus 2x all to the power of 3 plus 24x. And then part A, they simply ask us to differentiate it. So it's all going to be about differentiating. This is a curve, a quadratic curve it looks like. Actually that'll come in useful later on in the question. Alright, for now let's just start to try and answer part A. It asks us to find the derivative and the second derivative. Or they really just write dy dx. But we are expected at this point to know that this means the derivative. So let's go ahead and do this. It's actually a straightforward enough one. We have two terms, so you can do these separately. You can do this one first if you want, then this one. So let's just look at one at a time. Let's look at this first one here, because this is the hard one. Now this is a chain rule. So how we deal with a chain rule, something that has a big bracket like this, pretend what's in that bracket is just x. Just pretend it's x. So how do you differentiate that? The 3 comes down, the whatever's here, you're pretending it's x, remember, 3x squared. So that's how we use the chain rule, at least that's how we start it, because you're not allowed to cheat like that. You have to fix that somewhere. This is all proved if you learn about the chain rule. I won't go into it at the moment though. So what we still need to do is differentiate what we ignored, what we skipped, what's in here. We need to differentiate that. So let's see, the derivative of 3, 0, I don't care. The derivative of minus 2x, well that's just minus 2. So we need to multiply that on. And that's this differentiate. Let's continue on. We'll differentiate 24x. That is just 24. Remember when we differentiate just an x, it's like we multiply by the 1, 24, and then x to the power of 0. And x to the power of 0 is 1. So that's how we get that. Okay, so that's pretty much it. I guess I can clean this up a little bit. Minus 2 multiplies by 3, we get minus 6. 3 minus 2x squared plus 24. Alright, that's the first half of part A. Then they ask us to find the second derivative. The second derivative of x. And let's see. Right, so we just need to differentiate this. We continue on. Just like before, we can do this part first or this part. Hell, this part's going to be 0. It's just gone. There's no x's there, so we can't, the rate of change of x, when x changes, how much does this move? Nothing. So that's why that's 0. So we get the chain rule again. Let's see, we differentiate here. Minus 6, well minus 6 is just a number and it's multiplying, so it'll just stay a number and just stay multiplying. So we can ignore that for now. So it's just another chain rule. We get 2 multiplied by whatever's in the bracket to the power of 1. I won't bother writing in 1. I think we're all old enough to ignore writing the 1 in now. And then remember, I still need to differentiate what's in the bracket. I ignored it, remember. So we still need to differentiate that. We get minus 2 again, the same sum. Plus 0, so that's gone. Right, we can clean this up. Let me put a bracket in there to make sure. That's not 62. That 2 came down and multiplied. I should have put it in a bracket. Okay, let's clean all this up. We have 2 times 6. That is equal to 24. We have a minus times a plus times a minus. That's 2 minuses. Make a plus. And we have 3 minus 2x. That's it. You can leave your answer like that. Or if you would like, you can multiply it out. We will get 72 minus 48x. Either way, there are your 2 answers. Well, I'll try and leave these here because I'm going to use them. Yeah, this is quite short, the rest of it actually. Oh, no, part B isn't too short. Still, I can fit it in though. Okay, part B asks us to find the coordinates of each stationary point. Now, how many stationary points has this got? I'm sort of going to answer part C now, because I like to think about that when I'm doing these questions. I like to think what shape this is. I like to think what I understand about it. And actually, we should be able to understand this one a lot. It's just to the power of 3. So only an x in here. So we'll end up with, I don't know what, well I do know what it'll look like. We'll end up with minus 8x cubed. I don't care about the minus 8 though. What I'm interested in is, I guess, the minus part and the x cubed part. I don't care what number is there. And then we'll be left with squares, x's, and numbers. I understand that shape a lot. That's just a cubic, one that looks like, well, because it's a minus, let's see, when we're a really small number, a minus a million, will be minus times minus times minus times another minus. 4 minuses and a really big number. So 4 minuses are a plus and really big. We'll be somewhere up here. When we're a really big number, a million times a million times a million is a really big number. Plus 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 times a minus. So we'll be somewhere down here. So the shape, we all know the shape of quadratic cubic equations. Well, we should at least. They look like that. Anyway, that's pretty much answers part C. We'll get to that in a minute. But B asked us about stationary points. And well, all we need to remember, well, not all, but the main thing we need to remember about stationary points is the derivative equals 0. Remember, a derivative is also a slope. So the slope is 0 at these two guys. So here's the derivative here. We can just do some maths on that. Minus 6, 3 minus 2x squared plus 24 equals 0. Let's just rearrange things. Take 24 off both sides. Divide by minus 6. Let's do that both at one time. Slow it down if you need to. So I'll take 24 from both sides. We get minus 24 over here. Maybe there's still a minus 6 here. So now divide by minus 6 both sides. It's gone. Minus 6. If you did that in the wrong order, you would be in trouble. Let's see. 3 minus 2x squared equals, that goes in 4 times. Minus minus divided by minus is a plus, so it's plus 4. Yeah, we don't need to multiply this out and get a quadratic. It's much easier to do it the way it is. Let's get the square root of both sides. Well, not quite the square root, because plus or minus 2 could be the answer here. So basically, what multiplies by itself to get 4? Well, it could be plus or minus 2, so I need to be careful there. Let's stay rearrange it here. Minus 2x is equal plus or minus plus or minus 2 minus 3. Too many squiggles. Minus 3. And let's see, divide both sides by a minus 2. So that's x is equal minus 3 plus or minus 2. I think it's better to write that way. It looks a bit confusing. All divided by minus 2. So what's our two answers? We could have minus 3 minus another 2 gives us minus... Sorry, let me just check if this is right. Yeah, minus 5 divided by minus 2, which is plus 5. 5 over 2 is one answer. Another answer is minus 3 plus 2. That gives us minus 1 on top. Sorry, minus 3 plus 2 would give us minus 1 on top, and a minus 1 on the bottom will give us 1/2. Now that's not quite the answer yet. That's two answers for x. So we found this guy and this guy. Obviously my drawing's a little off. Let me actually just take this line out to fix this. A half will be first, so it'll be somewhere like here, let's say. There's a half, and here's 5 over 2. But yeah, it's not the full answer. They wanted the coordinates, so they also want the y. This is gonna. I have to redraw this because this is gonna be wrong as well, I'm guessing. We want the y part and the y part. So let's do that. I don't actually have the room. You know what? I have it done out already. I think I'll trust you guys to do it yourself, because here is y equals. Y equals. And we know what x is. X is this number here, 5 over 2. Put 5 over 2 here, put it all in a calculator, and you will get out the answer 52. So these two guys are coordinates. If you put a half in here, put all of this in, you will get out the answer 20. This is a coordinate. Let me write them again. Yeah, this drawing's bad, so let me rub this out and we'll draw it again. So if we put in the lines here, we know a point, a half and 20. Let's put that here, let's say, and we know a point 2.5 and 52. Let's put that over here somewhere. And we know when we get really small, it's going to go up here. And we know when it gets, it's meant to turn here. And we know when it gets really big, it's going to go down here. So that's roughly what that shape looks like. There are 2 points. We don't need the shape. Well, I'm drawing the shape because I can actually answer part C without doing any other maths. Because I drew the picture, I can go ahead and say, well, this guy here is the minimum and this guy is the maximum. Now, I think you'd want to write a little English with that, explain how you knew that, if you know that. Although, how they really wanted you to do it, because they made you get the second derivative here. How they really want you to do it is, they want you to put a half into this sum here, and you will get 24. 72 minus 24, I should say, which is 48, which is bigger than 0. Therefore, this guy is a minimum. Or they would like you to put 2.5 in here. 5 over 2 would give you, let's see, 24 multiplied by 5 is 120. 72 minus 120 is less than 0. So that would give, this guy would give you a maximum. So they'd like you to do that either way. I think the easiest is probably to use this here. If you already have it done out, use this. But if you understand what the picture looks like, there's no need to do this. If this is a simple cubic, if you understood how it looks, there was no need. It's very straightforward, which is a minimum and maximum. Okay, if you have any questions about that, any of the maths, or more likely if you have any questions about what I did here at the end, let me know in the comments below and I'll do my best to get back to you.